Okay, now we're going to look at number 3, this time around from the vantage point of integrating with respect to y. So, anyway, utilizing what we had from the functions, okay, again we had the cubic root expression whereupon y is equal to the cubic root of x minus 3. And once again we have the linear function y is equal to x minus 3, and we're going to look at integrating with respect to y, and so we're going to write the functions in terms of x equals. Okay, so if we cube both sides to eliminate the radical, we have that y to the third is equal to x minus 3. And so we're going to have, in this particular case, okay, it's going to follow that x is equal to y to the third plus 3. And with a linear expression from y is equal to x minus 3, converting in terms of x equals, okay, we're going to have that x is equal to y plus 3. Okay, now, in terms of setting up what we have in terms of graphing, we'll do a rough sketch here. Okay, so we have, once again, the points of intersection, whereupon we have at 2, -1, (3, 0), and 4, 1, and lining up what we have. Once again we have the linear function x is equal to y plus 3, and with the curve this time we have the x is equal to y to the third plus 3, okay. And so with activity that we have going on, okay, if we look at integrating with respect to y, okay, we were looking at horizontal slicing. Okay, if you notice, okay, between 2, -1, and 3, 0, we have x equals y cubed plus 3 is to the right of x is equal to y plus 3. We'll call this area R1, and we'll see that for R2, going past the intersection point at 3, 0 proceeding to 4, 1, we now have a role reversal where the linear is to the right of the cubic. Again, with that horizontal slicing, okay, y plus 3 is now to the right of y to the third plus 3. Okay, and so for what we have in terms of the total area, and the area of R1 plus the area of R2, and looking at this integrating with respect to y. Okay, this time we are going from y is equal to -1 to y is equal to 0 in R1. And again, right minus left. We have y to the third plus 3 minus the quantity of y plus 3 dy. Then we have for second region, again going from y is equal to 0 to y is equal to 1, y plus 3 is to the right of y cubed plus 3. And so for what we have for the area in region 1, okay, what's going to happen here, we have going from -1 to 0, 3's will cancel, and we have y to the third minus y. And again, just where the second region we have going from 0 to 1. Okay, and then we have again second region going from 0 to 1. We have the role reversal. Again, the constants will cancel, but now we have y minus y to the third. And so for what we have in the ensuing development, okay, with the power rule of integration, y to the fourth over 4 minus y squared over 2 as y proceeds once again from -1 to 0. And again for the second region, with y going from 0 to 1, this time we have the antiderivative difference between y squared over 2, which has deducted from it y to the fourth over 4. Okay, so we have, in this particular case, sorry, we say have. A little bit redundant here, but upper limit goes to 0. Now for -1 to the fourth, that would be a positive 1/4. But we are going to apply subtraction since -1 is the lower limit after all. Okay, so you have 1/4, and then we have -1 squared is a positive 1 over 2, but this is being subtracted so far. Then we have, with the upper limit at 1, so we have 1/2 minus 1/4 lower limit again is going to 0 out. And so we have 1/4 minus 1/2 is a -1/4, distributing the subtraction. Okay, we have 1/4, 1/2 minus 1/4 is a 1/4. And once again we have for the final result in terms of the area in sum. The area of R1 is 1/4, area of R2 is 1/4, and so for the collective area, this once again comes out to the value of 1/2.